All right, I'll try to go over this real quick. It's been a while since we made a video, but I want to make sure that you guys knew we are always hard at work in the shop. Always hard at work making new products to help your car perform better on the street and off-road. In this case today, we have some support from Boundary Performance Pumps. Boundary Lubrication Systems is a trusted name in the industry, and they've built oil drive systems for all kinds of vehicles, both on-road and off. They are a trusted name in high performance, and they are today our proud sponsor of new dual pump 3D Wedge Gerotors for the dual pump rear differential. For most of you who don't know, this is the inner workings of a Honda dual pump assembly, commonly found in the Honda CR-V and Honda Element and Accord Crosstour. These differentials use a hydromechanical engagement system, and in most cases, these would be the limiting factor for how soon your vehicle is able to transfer power to the rear differential. In this case, Boundary has worked on a new 3D wedge gear rotor design, and this gear rotor wedge design will provide us much additional oil volume transfer through the dual pump assembly to engage the dual pump piston through the center orifice, or the collector as I call it, to send pressure to actuate our racing diffs moly ceramic clutches. You can see these are the OEMs here. Vastly different, pretty basic design, but very complex. Good job, Honda. However, these original pump gear drives were not designed for high performance. They were designed for reliability and a practical approach to putting power to the ground. In this case, you can tell the 3D wedge rotor design is much more advanced. These gear rotors, we've been told, will provide us an additional 30 to 40% oil volume, but immediate bottom end or low end response. For those of you who don't know, this dual pump assembly is essentially a pressure differential system. So what it does is the forward portion with the piston on it has a forward gear, which it's a small one here. And then the center pump or rear pump, which is your primary pump, has its own gear. Now the rear pump is driven off of the ring and pinion itself, typically receiving its RPM from the rear wheels. And the forward pump receives its pressure or its RPM from the transfer case. So how this differential works, or this pump works rather, is when the primary pump senses a differential in hydraulic pressure between the front and the rear, or the differential receives a difference in wheel speed or RPM between the front wheels versus the rear. One pump is overdriven, causing a buildup in pressure here in the center of the pump, which actuates the piston on the other side of the forward pump assembly, engaging the clutches. So when you look at the difference between the generations, or generationally look at the difference between the differentials as they are set, you have for both B and K series a 2.542 to 1 ratio coming off of the transfer case. What this nets is at the rear two different style of differentials, one of which is a 2.533 to 1 ratio, which is the older 97 to 2004 CRV or the 03 to 11 Honda Element. Or you have the 2.562 to 1 ratio, which is commonly found in the 2005 CRV, 2005 to 2011 CRV, and the 2010 to 2015 Honda Accord Crosstour. Now, what makes those differentials vastly different is one of them has a mechanical ramp assembly. We'll talk about the mechanical ramp assembly a little bit later, in some videos we're going to be making to essentially clear the air between these different versions and what their performance benefits are to you. But essentially, the mechanical ramp assembly puts down 20% mechanical energy using a ball and cam design. The ball and cam is designed to send essentially an eighth of an inch worth of downward pressure on the clutches to engage them prior to hydraulic pressure buildup. This gives you a much more responsive differential with the ability to still muck your way out of whatever you're trapped in off-road, or put power to the ground to get your car to move a little bit harder off the line initially. With these new boundary pump 3D gear rotors, there is no need to worry about that. And we're going to be testing these sometime later on this month. Essentially, these new 3D Wedge Gerotors will provide additional volume almost instantly, it would seem. Essentially, they are a high arc design, so a wedge design, versus OEM, which is a straight cut gear. And they will provide a lot more pressure sooner, so more sensitive to RPM variations between the front and rear, and essentially faster at responding to pressure differentials between the gear wedge rotors. So this will allow this differential to assume the additional power and performance that the fluid dynamics will allow, essentially making full use of the flowing capability and pressure differentiation between the front and rear almost instantly. This system is a prototype, and this will be going into Carlos Alamir's differential in his full-time or real-time all-wheel drive rear differential. So we're going to set him up with these, and we're going to kick them out, have him start testing them immediately, and see how much power his 1200 horsepower AKD built all-wheel drive converted EG hatch will put to the street. More coming. Thanks, guys.